Hello, calculus fans. All right, let's find the interval of convergence of the sum of log n over n times x to the n. All right, so our usual sort of approach will be to apply the ratio test. Sometimes we'll apply the root test when we see nth powers, but usually we'll just use the ratio test. All right, so we're going to compute the limit of a sub n plus 1 over a sub n. So you should be able to see the a sub n plus 1 here and the a sub n here, but flipped upside down because we're dividing. If we clean this up, you should be able to see the log of n plus 1 over log of n. We collect those together. N over n plus 1, we collect those together. And the x to the n plus 1 over x to the n, we collect those, but we still have an absolute value of x. You should be able to see that these cancel mostly just to leave the x, but we have to have the absolute value of x. All right, now what we're going to end up doing is deal with each one of these limits separately. Okay, so it's easy to see that the limit of n over n plus 1 is equal to 1. Highest order terms, right? Now we're going to have to worry about the limit of log of n plus 1 over log of n. We're going to use L'Hopital's rule on that. Now, in order to use L'Hopital's rule, we really have to write it with an x. So we write limit of 1 over x plus 1 all over 1 over x. That's because we're applying L'Hopital's rule and computing the derivative. And so we get limit as x goes to infinity of x over x plus 1. And of course, that's equal to 1. So we can conclude from this that the limit as n goes to infinity of log n plus 1 over log n is equal to 1. So if you go back to our limit, our ratio test calculation, we're just going to get absolute value of x because the other two fractions are going to 1. Now we want absolute value of x to be less than 1. So that's going to give us a basic interval of convergence of -1 to 1 that's open. All right, I'm kind of making up this term, basic interval of convergence, but I think it's pretty useful. It's talking about the open interval of convergence that we get just from our ratio test or root test calculation before we test the endpoints separately. You're unlikely to see the phrase basic interval of convergence in any book. This is kind of a term that I've made up. You might see it, but it's not really a common phrase. All right, so we're going to test x equals -1 and x equals 1 separately. Now remember, when we do these separate tests, it's pointless to use the ratio test. And as it turns out, it's also going to be pointless to use the root test. You should think of the ratio test and the root test as sort of going hand in hand. All right, so let's try x equals -1. So we're testing this series where we're summing log n over n times -1 to the n. All right, looks like maybe we can use the alternating series test. All right, so Bn is the positive portion, ignoring that alternating part. And we have a couple of questions that we need to answer. Is B sub n decreasing? I don't think it's really clear just by looking at it. All right, so let's let f of x be equal to log x over x, because I want to take a derivative. So f prime of x is equal to low d high minus high d low, square the bottom, and away we go. So that's 1 minus log x over x squared. So the question is, how do we make this negative? We want this f prime of x to be negative. Well, log x is going to have to be less than 1, and so for that to happen, that's good enough. We only need the sequence to be eventually decreasing. So we've proven that the function is eventually decreasing. That means the sequence b sub n is eventually decreasing. Okay, what about the limit of b sub n? Is that going to be equal to 0? All right, this looks like a job for L'Hopital's rule because the top's going to infinity and the bottom's going to infinity. So we get limit of 1 over x all over 1. And that's 0. All right, so we've proven the two conditions that we need. The b sub n's are decreasing and they're going to 0. So the alternating series test tells us that that series converges. All right, how about x equals 1? So we're testing the series, the sum of log n over n. And we actually tested this before using the comparison test. If you'll remember, we said that log n over n is bigger than 1 over n. And since the sum of 1 over n diverges, remember it's the harmonic series, by the comparison test, the sum of log n over n diverges. All right, so we've got our final result. The series converged at -1 and diverged at 1. So we can say, therefore, the interval of convergence of our power series is -1 to 1, closed at -1, open at 1. All right, that's all for now.